This is the question doing now. Is paper 2 2016, number 3, part 2. And they want us to find the equation of the tangent to the circle at the point minus 1, 6. So let's do that. Remember, first thing you want to do for a question, write down the information that they give. We already did the first part in a previous class, and we got that the equation was this. But before we did all that, so just showing you what the equation was, we had already found out that the center, the center was 3, and it told us the given point, so the point at which the tangent meets the circle, it told us that point is minus 1, 6. So what you need to do is recall the steps to find the equation of the tangent. The first thing you want to do is find the center. But no need for that, we already know what that is, it's 1, 3. So first step, finish. Second step, we want to find the gradient. So I'll put m. Remember, gradient can be denoted by m of the radius. Why? Why do we have to find the gradient of the radius? You'll find out as we move on, as we continue the method. So we know that the gradient, the formula for gradient is y2 minus y1 or x2 minus x1. That's when given 2 points on a line. So say this is my, let me draw it for you. This is the circle point, which is my center. This is my given point, so 1, 6. And we know that the radius connects these 2 points. This is my radius. This equation is to find the gradient of a line when given 2 points on the line. We are given 2 points on the line. We know the point for the center, 1, 3, and then we know the coordinates for the given point, minus 1, 6. So we could use this formula. And substitute the values. So what I need to do is identify x1, y1, x2, and y2. So let's just say I want this to be x1 and y1, this to be x2 and y2. All I have to do is substitute these values into my equation to get the gradient. We said y2 is 6, so I put 6, minus y1, which is 3, so I put 3, divided by x2 is minus 1, minus x1, which is 6 minus 3 is 3, minus 1 minus 1, that's minus 2. So now we know that the gradient of the radius is minus 3. Step finished. Now, this would explain why we had to find the gradient of the radius in the first place. The third step, because we're trying to find the equation of the tangent, says to find the gradient of the tangent. Why do we need to find the gradient of the tangent? Because they want the equation. And we know that the equation of a straight line is y is equal to mx plus c. And in order to write it in this form, we need to know what the constant m is, and we need to know what the constant c is. So right now we're trying to find what m is. We're trying to find the constant m. And here's where the gradient of the radius plays a part. So we know this yellow line is a tangent, needs to circle only once. And we said in a previous class that the radius, which is this green line, is perpendicular to the tangent, which is the yellow line. Perpendicular means they meet at right angle. And when we were doing straight lines, we said that if lines are perpendicular, then the product of their gradients would give me -1. So m1, which in this case would be the gradient of the radius, times m2, which is the gradient of the tangent, would give me -1 because they're perpendicular to each other. So m1, gradient of radius, is -3m2 times m2, the gradient of the tangent, that's what we're trying to find. And we know since that these two lines are perpendicular, the radius and the tangent, we know that the product, so m2 times -3m2, would be equal to -1. What we need to do now, find m2. And m2 would be equal to 2 and 3. So this step finished. 2 and 3. Fourth and final step. Is to find the equation of the tangent. We know there are two ways to find the equation of a line. You could use y is equal to mx plus c, or you could use this, mx minus x1. There's a catch when finding the equation of the tangent though. This right here allows us to find the equation of any line when given the gradient of the line. So when given m of the line, and when given a point on the line. So point on line. Very important. On line. The point must be on the line. Must be on the line. I need you to notice that for the tangent, the only point that lies on this line is this purple point, which is the given point. And that's why when finding the equation of the tangent, you have to use the given point. You cannot use the coordinates of the center. So what I do now, I substitute. To put back y minus y1 using the given point. We have to use the given point because that's the only point that lies on the tangent. So y minus y1 is 6, is equal to m. M in this case refers to the gradient of the tangent. So we put 2 and 3. Put back x minus x1, which would be -1 in this case. So it's subtract -1. Now we need to find the value of y. Why do we need that? Because we need it in the form y is equal to mx plus c. So we need to find what y is. Y minus 6 is equal to, we could expand these brackets, 2 and 3x. Minus and a minus is a plus. So this becomes 2 and 3x times plus 1, which is just 2 and 3. This is just transposing. In order to get y by itself, we need to add 6 on both sides. So we get y is equal to, this is the final answer, 2 on 3x plus 20 on 3.